First of all, if I introduce myself, my name is Jitin, as mentioned by Aishwarya, and I'm an Azure trainer, and I've been working as a solution architect since last around 2 years now. So I basically specialize in technical pre-sales in Azure technologies, especially Microsoft Cloud, Microsoft 365, and other Microsoft Cloud services. So we are here today to talk about basics of DevOps and how you can basically go on to proceed to learn DevOps and its various principles, which you will be coming across while you learn DevOps. And we will be covering what is DevOps, why do we use DevOps, and various different principles which are practiced in DevOps. So let me just quickly share my screen and then we'll start. So I hope everyone can see my screen now. Let me just put it on full screen mode. Okay, perfect. So if I talk about DevOps, and so as mentioned here in this presentation, so this is not focused on any specific certification. And my goal is to teach you DevOps and basically fundamentals of DevOps and what actually DevOps on the whole is. But however, the things which you will learn today will kind of be useful when you opt for the DevOps engineer, which is your AZ 400 certification. So what is DevOps? So according to Donovan Brown, which is who is a kind of a chief evangelist in Microsoft for DevOps practices, DevOps is the union of people, processes, and products to enable continuous delivery of value to your end users. And what it does is it really unifies the teams so that they can work better together, they can collaborate on the projects more effectively, and in the end, bring the benefit to both business owners and their users. So before DevOps, what used to happen is, let me just quickly try to show this. We had a business owner whose kind of uh, guiding star, as you can say, was to generate value. And he employs, or say in a project, there's a person who works on the who works as the developer and whose developer's guiding star is kind of create new things, and creating new things and features is something how developers are paid and how their performance are evaluated. And traditionally we also have one other team in our projects, which is operations. And the value, or you can say the goal of operations team is to ensure stability in the operations, make sure everything's running correct and no service is down, no servers are uh, performing underwhelmingly, or any every updates are pushed through effectively. So as you can see, the developers and the operations team have some conflicting goals. Developers want to push new stuffs, and pushing new stuff is the best way to create instability to the current software or the environment. So the purpose and between all this, business owners have a certain set of requirements. business owners have certain set of requirements which they have to fulfill as part of their project. So this conflicting goals really makes the project delivery time longer because basically developers and operations team cannot coordinate or collaborate that effectively as is expected by this business owner. So that's where the role of DevOps come in. And what DevOps does is they unify these teams. They unify these teams using different set of tools, practices, and as you can say, culture through which all these teams can do their work effectively without hampering in each other's work. So let me just quickly spring back to my presentation. So we just discussed what happened, how it used to happen before DevOps. And, and as I said, the goal of the DevOps is to deliver the value to our end users. And as I discussed here, the developers always want to create new features which the operations team doesn't like, because pushing new stuff is kind of making sure to introduce instability to the system software. So using DevOps, we plan to counter all this so that both these teams can collaborate effectively and they can work together on a project which delivers the value to your business's users. Now, one of the one of the key principles in DevOps is being agile. So earlier, what used to happen is you must have learned about the waterfall project method, and what waterfall method was, you had a customer who had certain set of requirements, and he passed those requirements over to some business or some company who will deliver those projects to that customer. And then the company started working on the project. First, there's a design phase. Then they develop that project. Then there's testing, and the last stage, and they delivered the project in the last stage. So as you can see why this is called a waterfall method, because the production flows like a waterfall. And between all this, the interaction with the end customers only happened during the final delivery phase. So customers is only interacted during the final phase of this project. So let's say, and doing this takes a long time, right? Sometimes it can take 4 months, sometimes it can take 6 months. So if there are any new things or new features which customers would like to implement, he would only be implemented after this delivery phase. And he would have to wait all this time during the design, develop, and test phase only to be notified at the delivering phase that some new features has to be pushed. Or let's say you have been working on this project since 8 months and you deliver the final project to customer, and there's something which customer doesn't like. So all you all things you did here would be kind of not worth it, because in the end the customer doesn't like your project, like your product. So to counter all this, we follow the agile mindset. And in the agile mindset, what agile mindset is, so what agile mindset is, it's driven by four key values, and the customers is involved constantly in every phase. For example, in agile, we don't tackle project as a whole. We divide our projects into smaller batches and build our new project on top of our previous batches. For example, let's say we have a project which is this big. We will divide this project into smaller batches. Let's say I build this one first. I've built this much first. Then after that, I build this much. And then finally, combining all that, I build this much. So what it does is we still have the customer in Agile, but the customer is kept in loop throughout the process. So the customer is part of the every process. Customer is part of the every process, and he's kept in loop throughout the life cycle of this project. And doing this, even if so we have some minor changes in between which customer doesn't like or he would like to add, we can implement it during the earlier stages before we actually deliver the product. And every phase, even as small as this phase, has similar four phases like we have usually in our product lifecycle: design, develop, test, and deliver. So each of these smaller loops you can see consist of these four stages in smaller batches, and the new batches are are built upon the previous one. So this is built upon this one is built upon this one is built upon this one. So you don't make a project as a whole, and you can implement design changes and any new features, or let's say there's something which your customer doesn't like, you can introduce that change early on in your project, let's say at this stage, so as to not waste your time in delivering the whole project and only to realize later that there was a thing that was needed to be added. So this is what uh, agile basically means. And in agile, there are basically two concepts which we talk about a lot. So the first one is Scrum, and the second one is Kanban. So let's expand a bit on what is Scrum. Okay, so if I expand a bit on what is Scrum, so in any project, you have a product backlog, correct? So the backlog consists of different tasks which are to be performed as part of your project. And every task has a different priority based on what that task accomplishes in that particular product. So let's say this particular task has a priority level of 9. This has a 10, and let's say this is 1 and this is 3. So what Scrum does is, in let's say what we do in Scrum is we we develop our products in sprints. So let's say in our first sprint, we in our first sprint we design, we develop, we test, and we deliver that particular task from your backlog. And let's say we took the task with the highest priority first. So let's say we took the second task, and we will name this as sprint 1. So after this sprint is completed and everything's working well, we will move on to sprint 2, where we will be developing our next priority task. And let's say we take this one, and we will design, we will develop, we will test, and we will deliver. So similarly, we will perform few more sprints until all our tasks are completed. Let's say it goes on till sprint 4. So in the end, we combine everything and deliver our final project. And doing this, the customers, again, we have a customer here as well, or let's say we have a requirements, and he's involved during the every sprint. And doing this, as mentioned earlier in the agile, he's involved in the every step of the process, and all the changes and updates can be, implemented timely, or any new feature can also be added on a timely basis. Now, if I talk about the next topic, which is our Git and CI/CD. So as a part of a developing team, they are based out of they are placed all over India, correct? So you may have one of your developers working in New Delhi, and you may have someone from your operations team who is sitting in Hyderabad. So let's say this is your project, and you have one person who is sitting here. Let's say he's a developer, and you have a guy from operations here as well. So these two guys really need something to collaborate, like, because the code which he develops is stored in his local machine here, and the operations team has some copy of code on his or her particular local machine. So this is to create a centralized repository of code. This is what Git offers. So what Git does is, so what Git, so what Git does is, it gives an access to a centralized code repository to which the developer can push the code, and the operations team can pull any kind of code to ensure everything is working correctly. And there are some kind of standard tool sets which using which the developers and operations team can manage their Git repositories. And this kind of Git systems is the distributed kind of uh, let's say repository, where the code's copy is kind of distributed between all your teams. And for accessing this repository copy, you will need a centralized repository. For that, we have our GitHub, we have our Azure DevOps repos. So there are many kinds of these repositories which you can use in order to access that centralized repository. And in these repositories, people will make commits. Uh, Commits can be of their codes, and people will pull and push their commits so that they can collaborate and operate and work on that project that effectively. So A part of this process is also continuous integration. So let's say a developer commits a, a developer commits a code into the repository. What it can do is it can trigger a pipeline. Let's say it triggers a pipeline, and what it does is we need to make sure that code is non-malicious and break or it doesn't break or do anything we don't intend to do in our project, right? So that pipeline will make sure that all the security practices are in place, things are being built correctly. It will perform some tests to make sure that the code which we are going to push is going to run smoothly or it doesn't break anything. It will create an image and it will upload that image to a certain registry. Now, so as mentioned here, continuous integration is used to find bugs or any kind of incompatibilities early on in the production. And continuous delivery and deployment deliver value to the end user. So the next part of the process is the continuous delivery, right? So after continuous deployment, and let's say we have everything in a centralized registry. So this will again pass through a pipeline. And let's say I continue this pipeline here. And what this pipeline does is build your infrastructure of the specific code, deploy. So it can either deploy an artifact or an image. It can test. It can test that deployment well to make sure everything works correctly. And then we have some sort of gate here. So in this case, we can have our work items, our bugs, or any kind of approved pushes or any kind of time window which we want to implement into our pipeline. Then this code is again passed through the UAT infrastructure and it's passed through deploy UAT. Then again, similarly, it will be passing through the test UAT. So again, we will have, so again, this is a continuous pipeline which is built as part of our project. And this pipeline really makes sure that the code which we are going to commit is passed through the various stages so that it doesn't break our production. So another most important part of our production or say our project is to ensure the continuous delivery and continuous deployment. So for continuous deployment, as soon as the code passes passes through all this pipeline, it's passed through another deployment pipeline, which verifies the product infra. It deploys your product and it performs some necessary tests before it's being actually deployed. So this is part of your continuous delivery. So this continuous integration and continuous delivery together forms continuous deployment, where you are make sure you are making kind of sure that your services aren't affected when you commit to a new code, and making sure everything's working perfectly fine when you deploy everything. Now, if I talk about our next topic, which is importance of monitoring. So monitoring is always important to make sure that how the systems are behaving. But for DevOps, it's much more important because it usually consists of the interactions and user behaviors. Because how monitoring done in DevOps is that you have an user, so you gather and your user has certain experience of using your product. So you gather their feedback to learn more about your product and how the user is interacting with the product, and based on the feedback you will build on your product and make some necessary changes. And you can also take some telemetry data from your users, where your product must be used by your end customers via some electronic device. Let's say it's a mobile phone via some application. So you can collect that telemetry data from their mobile applications to better build upon your product and understand how it's behaving in the real world. And it could be in terms of, the monitoring could be in terms of user experience, and it could also be in terms of telemetry tracking, where you track how the users are using your application. And the monitoring can also be monitored as per how often you are releasing the key performance indicators or KPIs, and what is the sentiment of your users. So are your users happy, or could they be more happier, or is there something about your product that they don't like? So this all topics come under the monitoring part, where your primary goal is to take the experience data of your product and make some necessary changes according to your collected data. Now, now if I talk about infrastructure as code, so what infrastructure as code does is you have a certain set of resources running, right? You have you may have some Kubernetes clusters, you may have some virtual machines, you may have some images. So every time you have to create these resources, you don't have to use portal, because the portal using portals can make a developer prone to errors, like because there are hundreds of services which are running in the portal, and there is always a chance of allocating a wrong resource or something like that. So, and also we want to automate all this so that you don't have to write you don't have to allocate the resource again and again. So in infrastructure as code, or IAC, the infrastructure is defined by some kind of code. So it can be a JSON file, and or it could be a YAML file. And using these files, you can directly deploy your resources without creating each resources one by one in the portal. And what's the advantage of this infrastructure as code is it's declarative. So you can really declare all the resources which you want to deploy. There's there's no special language which you need to run. You may need to learn YAML or JSON, but that's it. Your resources are in the declarative format, and they are idempotent as well. So you can redeploy these resources again and again as many times as you like. And what it does is it makes your infrastructure more human readable, and it also makes it easier to audit your infrastructure to make sure that everything that you are running works correctly, and whether or not you may have done something, you have deployed something wrong, it it can be easily verified using the declarative format in our JSON file. Now, I think we have covered ICD as well, and infrastructure as code as well. So if I expand a bit on monitoring as well, so there are certain set of tools which you can use to monitor monitoring in DevOps. So the Atlassian recently released a DevOps trend survey, in which over half the respondents said that their organizations had a dedicated DevOps team, and the 99% of the respondents indicated that DevOps has had a positive impact on their organization. So continuous monitoring tools that are critical component of the DevOps pipeline provide automated capabilities that allow developers to effectively kind of monitor applications, infrastructure, and network components in the production environment. So to help a comprehensive monitoring strategy, uh, in your software project, you can use different set of continuous monitoring tools. So as I mentioned, continuous monitoring is an automated process that leverages specialized software tools to empower DevOps team with enhanced visibility of application, performance, security threats, and compliance concerns across the entire DevOps pipeline. So some of the tools you can use for continuous monitoring is there's one tool called Akamai Impulse. So it's a real user monitoring tool that allows DevOps teams to collect and analyze experience and behavior data from users who visit their website or application. Then there's a tool called App Dynamics. So it's a continuous monitoring tool that supports infrastructure network and application monitoring of both cloud and on-premise computing environments. So DevOps teams can really capture data from infrastructure components, database transactions, applications, and user sessions, and some other sources to maintain a full visibility into the tech stack, and rapidly respond to performance issues before they kind of negatively impact the customer experience. Then there's a tool called Chaos Search as well, and we have a tool called Dynatrace. So there are many tools which are available for monitoring as well. So there are certain tools which are available for CI/CD as well. So if I talk about CI/CD tools, so as similar to monitoring, there are several tools which are available for CI/CD as well, and the development teams use these CI software tools to automate parts of the application build and create a document trail of the development process. And there are several things to keep in mind when choosing the right CI tools for your project. And when you select any kind of CI solution, you have to be also consider that whether it will be hosted on premise, or whether it will support your Docker, and whether the user interface is intuitive enough for your team and it's also easier to use. So some of the popular CI/CD tools, which you all must have also heard, is Jenkins. So it's an open source CI automation server, and it's kind of one of the leading continuous delivery and continuous integration tools on the market. So it's a leading open source automation server, and it provides hundreds of plugins to support building and automating any project. And once any project is tested, Jenkins also supports the ability to deploy a code with continuous deployment. Then you have GitLab as well. So it's a web-based Git repository manager with wiki, issue tracking, and the CI/CD pipeline features, which also uses an open source license. Then there's some tools like JetBrains, Bamboo, Travis CI, and and if I talk about Bamboo, so it's an on-premise continuous integration tool which is integrated into Bitbucket, and that ties your automated build, test, and releases together in a single window. So if I talk about tools which are used in Git, so versioning, when you version using Git, uh, Git version looks at your Git history and works out any semantic version of the commit being built. So it works. The Git tools work with most branching strategies, but most of them are designed mainly around the Git flow and the GitHub flow. Sorry, just a sec. So And Git, as you all know, is a version control system designed to track and record all the changes made to files and its code. So with its help, you can compare, analyze, and merge changes, commit them to the repository, and roll them back and restore the previous versions. So you don't really need to worry about making a mistake, or let's say losing your code. So more precisely, you will worry because you are a professional who cares about quality, not because you will lose your code or you may do something wrong. And to work with Git, you use the functional command line interface, and Git professionals consider this to be the right way. On the other hand, as an alternative, you can also use the Git graphical user interface. And some of the few top Git graphical user interface clients are GitHub Desktop, Git Kraken, SourceTree, SmartGit, Gitforce. So if I expand a bit on some of them, so Git Desktop, which is perhaps the most famous solution for working with Git in kind of a visual interface. It is familiar to all the developers keeping their repository on GitHub, and This GitHub Desktop is a free GUI, which is open source, transparent, and functional. So when you consider the Git graphical interface for Windows, GitHub Desktop is many times the first option which comes to mind when the companies are actually trying to work with the desktop versions. And with GitHub Desktop, you can create new local repositories quite easily. You can track all the changes and their authors visually, and you can also collaborate with other developers with while checking out the branches with easily. And you can also encourage your developers to code safely and much more. So GitHub Desktop is supported kind of by a vast community of developers, and they work continually to make the this Git and Git Desktop kind of better for every user. Another popular software solution that provides Git GUI is the source tree. So it's a free client software that allows you to connect to your repositories in GitHub, Bitbucket, Stash, or Microsoft TFS. And this is developed by Atlassian company, and it is a tool to make the life of Git specialist much more easier. It is simple and user friendly with transparent navigation and bunch of useful features. And you can easily perform all the necessary Git related tasks such as cloning repositories, pushing, pulling, committing, and merging changes. Both experienced users and beginners can work successfully with SourceTree, in which you can track all the changes, actions, and the actors. Now, if I talk about infrastructure as uh, tools which are used for infrastructure as code, so one of the tools which is quite famous is, I guess, Terraform, which everyone might have heard about. So as I said, the infrastructure as code is a set of tools designed specifically to make different systems as closely configured as possible. So they are a solution to the problem of inconsistent environments. And by provisioning cloud computing via code rather than doing them manually, as we discussed earlier, you guarantee that all your systems are the same. So ISE removes the human component of setting up your servers, virtual machines, and the provisioning your cloud computing through the automated process. Now, if I uh, talk more about tools, so as we talked about Terraform, so Terraform is kind of free and open source tool which is created by HashiCorp, and it is, I guess, one of the most popular ISE tools. And Terraform takes the declarative approach to the ISE with a pre-execution check in order to maintain the desired result, which has been achieved or not. And Terraforms is sometimes used as a base tool in conjunction with Ansible. So the open source nature of Terraform is makes it highly compatible with cloud services such as Azure, AWS, Google Cloud, and even OpenStack. And then if you use, let's say, AWS, so AWS has a native tool for ISE, which is CloudFormation, and it's an integrated ISE solution that comes with AWS platform, and it can also cover your DevOps needs and best practices for infrastructuring your code. And CloudFormation is another declarative solution. And since the software works specifically with AWS infrastructure in mind, the margin of error is small when you work with the native cloud tools. Similarly, Azure has its own tool, which is called Azure Resource Manager. So it's similar to CloudFormation. It's integrated into Microsoft Azure. And one of the most talked about benefits of Azure Resource Manager is that it's easy to use. And its ease of use is kind of a strong selling point for Azure Resource Manager, and it's really kind of helpful for people running their Azure workloads. Uh, but the only disadvantage I would talk about when using Azure Resource Manager is that you will need to learn some terminologies which is specifically related to Azure Resource Manager. And one of the, let's say, you can say a vital feature which Azure Resource Manager offers is the role management and resource management. Uh, and these two features are integral to the design that make resource allocation much more easier. And similarly, like I said, AWS and Azure, Google also have their own IAC tool, which is Google Cloud Deployment Manager. And you also have Chef, which is a procedural tool in which it describes the system steps to arrive at the final state rather than describing that state. And one of the strengths of Chef, if I talk about, is that it's a quite a popular tool that works with many platforms such as Azure, AWS, Google Cloud, and the widespread use of Chef allows the users to migrate to different cloud platform without even using their IAC configurations. And lastly, one tool which is most commonly used in IAC configuration is the Puppet. So Puppet is an open source tool, just like Chef, that can integrate with any existing platform. And the main difference between the Puppet and Chef is that Puppet is declarative and with some configured preferred methods to the IAC. As open source software, Puppet has a large community called Forge dedicated to improving and extending the Puppet. So these are some tools. These are some tools which are used as part of infrastructure as code. And here are some things which can help you get started into Azure DevOps. So then there's Visual Studio Code, then there's Git SCM, and here's the link for Microsoft Azure website, and you can review the GitHub and its pricing from this link here. And you can also see the pricing for Azure DevOps by going through this link. So I would So everyone, I would request to please note this down or take a screenshot or whatever you want, and please go through all these links and it will really help you, get started on all these services and everything. So I think it's time we move on to our questions.
Yes, so
Ashwarya.
guys, if you have any kind of question related to our topic, then you can come up with your questions. You can type your questions in the chat box panel and we'll take your questions. Okay, so it seems like we have one question. Mr. Jitin, can you please answer this
So
question?
I guess Gagan has asked what is a pipeline. So a pipeline, or you can say a DevOps pipeline, is a set of automated processes and tools that allows developers and operation professionals to collaborate on building and deploying code to a production environment. You arrange for that meeting or for detailed training on Azure. So It's Gaurav, I guess. Yeah. So Gaurav, we have many courses which are running from time to time on our website, and you can really check out our website for upcoming courses. From what I could recall, we have an Azure Fundamentals which is running next Friday, which is a free course, a free 1 day free course for Azure Fundamentals. And after that, we have some courses which is running for Azure Administrator, and a, we are sort of planning a course on Azure DevOps and solutions architecture as well. So as of now, if you guys need information about some courses, so we are planning to run Microsoft Azure Fundamentals, a full 1 day course, which is your 8 hours a day, let's say, and it's a free course which you can really join to understand more about cloud, or basically Microsoft Cloud, and how the Microsoft Azure platform works. And we also have some, as I said, some courses as running on administration as well, along with some courses on other Microsoft cloud technologies like Dynamics 365 and Office 365. So thank you, Aishwarya, for the website link. So please do check out this website link, and also check out our LinkedIn pages as well, where we post these kind of courses regularly. And we are planning to run many free courses on Microsoft Cloud in coming months, uh, August and September. So I think this would be something which you all will like.